Right, hello everyone. Yeah, I've been asked by a couple of YouTubers to have a look at this. It's on sale now in Aldi, and it's a newer version of this, which I reviewed on a previous video, which is the 18559. But now we have an updated version. I think this one is 3.8 amp peak charge. Okay, there's a couple of Achilles heels with it, which we went through. And if you're interested in this one, then look at this. I'm going to just review the new one and then just do a quick comparison of these two to see with the new ones any better. So this is the 5 amp offering, because Lidl upped the ante from 3.8 to 5 amps with their last version, which I also reviewed on a comparative review on the channel. So we'll have a quick look at this one and just see what the difference between this one, which is the old one, 3.8 amps, and the new one, 5 amp. Looks exactly the same on the packet. Okay, and if we look at the spec on the back, you can just have a quick look at that. You can see a bit more. There's not much on the website, and it doesn't actually, they're not stating it. It says 5 amp mode, current charge, and these approximations and everything else. Okay, yeah, so freeze frame, have a look at that if you're looking to, with a 3-year warranty. Good luck with that. Right, okay, so 5 amp AutoXS battery charger, right? And the number was 1979, MD19779. Let's open it up and have a look inside. Yeah, so it's an MD19787 battery charger, and it looks identical. So they've crammed another 1.3 amps of output from it. So let's have a look at the clips. We'll do a comparison of the clips. Kingdom for a clip. There we are. Oh look. Yeah. So first of all, we've got bigger clips for your nips. This has got the old one's got a stronger spring. That's quite okay. It's a longer lever, but if I hold it in the same place, it's a little bit weaker. You can see we've got screened battery connections here, so you can't short out on the inside of the wire, whereas these are pretty similar. Interestingly, look at that. That's nice. That's a nice touch. You can undo that, presumably. I'll just zoom in on there so you can see. Yeah, we've got funky clips. Look, funky removable clips. That's a nice touch, isn't it? If you want to wire this battery charger into something permanently, then you've got the option to do that as well. So that's a nice thing. I've not seen that on a battery charger before. So going the other way up. Nice. So make sure your terminals are tight. You said trying to get it back on. Clearly much more easily removed than replaced, like everything in life, isn't it? I've taken your virginity, I'm sorry. Right, okay, so you got 2 clips. It's the same kind of, actually the cable any thicker? No, the cable's the same with the old and the new. Take out the box. Zoom back out. Sorry about the desk. It's got all this bloody heatsink compound on it. Bloody stuff gets everywhere. Yeah, 13 amp mains plug with a fuse. What size fuse have we got? Is it a 3 amp? Should be, shouldn't it? All things being equal. If you haven't got any of these are called O-ring picks, and they come in different lengths and with different bits on the end, but they're great hard steel picks. I think they're Stanley or something, but yeah, get yourself a set of O-ring picks. You can always diggle into something and get what you're looking for. So a nice 3 amp fuse. It's probably alright. I'm not going to waste any time going into that anymore. It's not what we're interested in, really. Yeah, same tri-lobular screws in the back, and quick comparison. I'll set this up for you, and then you can freeze frame and read it if you want to see the differences. 0.8 amps, 0.8 amps, max 7.6 volts. So I've taken the maximum off. So for some reason they've not seen fit to repeat the maximum charge voltage, which is interesting. Yeah, all very similar in fact. The wheelie bin and the RHS symbols are in different places, but otherwise no difference. So is this the 3856 battery charger they made in 2020, as I bought this one last year, and it's 17,351/19. So that could be the number this year, but the number built followed by the year, the date. We'll see. All right, so let's, with further ado, let's get her plugged in, get her wired up. They're trying to make love to each other at the moment. Funny business on my bench. All right, so there we have it. Let's plug her in. Let's put some power into her. Actually, no, we'll run her off the power supply. Okay, so I've got it wired up. The DC electronic load is set, and the battery simulator voltage is set to 7.5 volts. So you can see the two voltages down here. The test equipment is up on the rack up there. But I put the meters down here just for clarity. So this one's reading the current, and this one is reading the terminal voltage on the actual clips of the battery charger. Okay. So now if we look in the book, I'm not going to bother with the 6-volt charging mode because no one's really interested in it, and in this battery charger it actually creates a lot of confusion because instead of charging your battery, the thing's trying to work out what battery is actually connected, whether you've got a motorcycle at 6 volts or a car. So if I just show you this is the charging process for a 12-volt car, okay, car battery. So scenario 1, you've left your lights on and your car's been fine, but you've accidentally left the lights on and the battery's run flat. Okay, so let's just we'll go through the rest of these higher voltage modes at the moment, but the important one is, will this get you back on the road and back to work? All right, because this seems to be the problem that people have been reporting with these chargers, is that if your battery voltage has gone below 10 volts or whatever, you know, it's quite flat but the battery isn't knackered, that it's buggers around for ages rather than getting back on the job of putting some charge into your battery. So let's just simulate that. So here you can see it says that a battery voltage of 7.5 to 10.5 volts, the charging process will take place with a charging current of 0.8 amps. All right, so I'm going to just turn the power on to the charger. The charger's already connected. Power on, and you can see the display flashes. Then you've got 7.6 showing, even though the battery terminal is 7.43. The test equipment is reading 7.496, so it's overreading slightly. It's not that voltage at all, it's 7.496, so it's 7.5 volts, 7.43 down here. So give or take, it's reading a little bit high, 0.1 volt high, probably, which is common to the other model as well. It reads too high, but only by 0.1 of a volt. We'll see if it tracks with 0.1 or whether when we go to higher voltages it does anything. So I've turned the unit on. I've got 7.6 on my battery, and here it says don't forget it should start doing something at 7.5. Right, so I'm confident in this setup. I've used it to test quite a few battery chargers and designs and things I've done. So let's move that piece of cleaning cloth out the way. So what's it doing at the moment? I can press this button and nothing happens. Okay, so your battery's flat, you've connected it, put the power on, and you can get it to do flashing thingy, but you don't know what it's doing. It's saying the battery's empty and it's 7.6 volts, alright, and it's flashing 7.6. So nothing is happening, there's no current, nothing happening at the moment. Let's see if it kicks in. It should kick in at 7.5. It should, according to this, charging should take place at 0.8 amps. So taking the instructions and the specification literally, it should start charging, but nothing is happening. I'm going to leave this. I might cut and see where we're at. We've been going for about 90 seconds so far, nothing's happened. So you're standing outside, you're freezing cold, it might be raining, and you're waiting for something to happen to get your car back on the road, okay? Nothing happening. I'm going to leave this for a few minutes and then come and cut back to you, okay? And we'll see when it starts to do something. Place your bets. Of course, it can't react to less than 7.6 because it might be a 6-volt battery, and if it starts kicking in with charge at 7.6 volts and assumes it's a 12-volt battery, it'll start to boil up your motorcycle battery, your 6-volt battery. Okay, so now look, it's done something. We've been going a couple of minutes and it's pushed the voltage up to 10.6 and charging, well, 10.6, 10.51 here, charging at 0.82 amps. Ignore that sign, it means I've got the, actually I could connect it around the right way, couldn't I, just for sake of accuracy. It's gone back. And I'm going to have to wait another 2 minutes while that starts charging again. I am, aren't I? Let's see if it recovers. I'm wasting all this time so that you don't have to. I'll see you in 2 minutes. So what's happened there is I've disconnected the battery and reconnected it, so it should start this 2 minute or so cycle. See if it says any instructions about it. Okay, we're 2 minutes in and it's just changed to 10.6 volts and it's on motorcycle and car mode. You see this, the indicator has gone straight to motorcycle and car, so it's a motorcycle car. 4-wheeled motorcycle? 2-wheeled car, you guess. So anyway, now it's doing what it says it does, so you've got 2 minutes to wait before something happens and it's analysing or doing something. 10.51, 0.821. Alright. Yeah, see, therein lies the problem. This is their problem, you see. They've got the 6-volt mode here. At a battery voltage from 3.7 to 7.6, the charging process takes place for the charging current of 0.8 amps. Right, so at 7.6 it drops back. So it charges a lead-acid battery at a voltage less than 7.5 and assumes it's a 6-volt and then goes up to 7.6. But, you know, if you disconnect your, say you were charging a 6-volt motorcycle and you quickly whip the clips off and the terminal voltage was 7.6, and the reason it's waiting 2 minutes is you might just be reconnecting your motorcycle battery and it's monitoring it because that 7.6 volts will drop down within a few minutes to below 7.5, in which case it knows it's still a motorcycle battery you're charging. If that voltage is stable at 7.5, it thinks it's safe to assume that it's a 12-volt battery, and it goes into this mode here with car and motorcycle mode at 10.6 volts. The reason it's gone to 10.6 is my DC electronic load up on the rack there is set to 10.6, alright? But so it's still charging at 0.821. So it switches straight in with a 0.8 amp charge. And I'm assuming now that I've been waiting around in the rain, and now I can press this and set this to car mode, or can I? So that's cold mode, motorcycle car cold mode, and if I press it again, goes to car mode and straight to 5 amps. So you can see straight away that the charger is supplying the advertised 5 volts, 4.998 amps, 4.990. My actual test equipment says 5 amps dead, actually 1 milliamp out, so I trust the test equipment, not this meter, because this meter is a cheap, 30 quid meter, but it gives us a good indication of the actual nominal current that's going through. So yeah, so now we are charging at 5 volts. So let's redo that test. Let's just turn off, reduce the car battery voltage down to 7.5 again, reduce the load voltage so the load will start to conduct at let's call it 7.8. so now it'll start start to draw a load and limit the actual output voltage 7.8, simulating a flat battery that's at 7.8. So let's turn the power back on. Can't do anything again with the button, look. It does something, but it just sort of does some random flashing mode. So let's just leave it for another 2 minutes. Let's put that one back on so you can see it. Okay, so we've got different. We're 2 minutes in again, and this time it's I'm limiting the terminal voltage to 7.8 volts. All right, so the battery is not going above 7.8 volts. So instead of going into a charge mode, the unit now is pulsing with a 0.8 amp, half second on, half second off, just over that probably. So you can see the current pulsing up to 0.8, and you see the voltage changing from 7.4, which is the battery uncharged, to the 7.8 volts, which is the battery clamping voltage, which is the simulated terminal voltage, the battery on the load. All right. So it's going to be doing this for a while, and it says battery car. So it's a 12-volt motorcycle, 12-volt car battery. And does it say what those indications are? Yeah, so that's what that is. That explains that there, look. Got the car and motorcycle symbol showing, so it's going to charge a maximum. If you just put it onto your car and walk away and wait for this 2 minutes to complete, it'll be charging at 0.8 amps, which will take for a long time to get your battery up. All right. So you do need to have intervention there to actually press this button to go into normal car mode. So let's go into car mode. That's cold car motorcycle battery, 12 volt. That's car mode. And you can see it's still doing the same behavior. It's pulsing the 0.8 volt amps pulse into the battery. It'll carry on doing this until the battery voltage recovers, but there's no consolation to you if you want to get to work, because it'll take forever, because we're only effectively charging. If it's on half the time, we're actually charging at 400 milliamps, and it'll take a long time to get your battery up sufficiently to start the car. So by wiggling the thumb wheel on the load, I can turn up the load voltage. Alright, so this is I'm turning up the terminal voltage. If you keep an eye on this voltage here, you'll see it will be pulsing between 7.5, and I turn it up. So we've got 8 volts, and at some point this presumably will stop this pulsing mode and kick in with a charge. So let's see when it does that. We're up to 8.2 volts. I'm at 8.5 volts, still pulsing, so you're still waiting. But geez, let's go and have another cup of tea, phone the boss, explain that your battery charger you bought doesn't actually charge your car battery if it's flat. And we're still pulsing, and we're up to, what are we up to? We're up to 9 volts. So up to 9 volts, we're still pulsing. Remember, this is the battery terminal voltage simulation I'm turning up here. 10 volts. 10 volts, and we're still pulsing, okay? So your battery will take a while to recover at this 0.4 amp effective nominal charge rate. And it still won't kick in with a full charge yet. So let's see what it says in the book. What does it say in the book? Read RTFM. Read the manual. Here we are, blind you. And 7.5 to 10.5. At 10.5 to 14.1, the charge process continues with a charge current of 5 amps. So when we get up to 10.5 or thereabouts, it should come up with the full Monty. Hold on to your hats. More power, Igor. .3, 20.4. Now it's kicked in. Okay, so we're on 10.4 volts on the load, and it's kicked in with the full 5 amps as prescribed. Now you're cooking on gas. You're going to get your car charged and you can go to work. But goodness knows how long that initial process. The trouble with that 0.8 amp charging process, that pulsing on and off, on 50% of the time off, is that if your car alarm or something has gone a bit iffy, that current can just be soaked up by your car alarm or your car electronics because they're in an indeterminate state because the supply voltage is too low to make the car BCM, the control module, which does take some current in standby, and the alarms take current in standby. And I've had a couple of posts from some YouTubers say, well, I had to disconnect the battery to get it to recover because that 50% charge at 400 milliamps was just going to power the car electronics rather than putting any charge back in the battery. So in some instances you're going to have to disconnect your battery, which is another faff that you'll have to do if it won't recover. But it might be some time before you discover that that's the problem. So another drawback of these multi-battery chargers, 6 and 12 volt dual mode, is that there's some, it doesn't know what's connected, so it's a bit afraid of doing the right thing. So anyway, at 10.5 volts we kicked into 5 amps. We're running at 5 amps. It's quite cool at the moment, actually. Let's just turn the power meter on and just see what efficiency we've got on this thing. See if they've done anything radical with the power circuitry, because the old one got very hot at 3.8. That was my phone, don't check yours. Yeah, so actually real power, we're pulling 70 watts. So 5 amps at what voltage have we got? 11 volts is 55 watts. We're pulling 70, so yeah, it's 55 over 70 efficient, which is what exactly? I'm going to hit you with the 55 divided by 70 times 100. Oh, yeah, 78% efficient, which is not that bad actually. And we've got a power factor of 0.54, which is bloody awful. But we don't worry about that unless they switch to VA meters, do we? Because the power companies are paying for the extra losses in the power lines and the transformers and industrial customers. So anyway, 11 volts, 5. Turn this phone off. Hold on a minute. Who wants to speak to me so badly that they keep pinging me messages? We hear system sounds now. It's not my fault. It's Windows 10's fault. Right. Okay. So anyway, cruising at 55 watts at the moment. So anyway, 5 amps. Just over 5 amps. Still pretty cold, They may have done something amazing. We're going to open this up in a minute and have a look inside and compare it to the old one, just see what they've done internally to make this thing run a bit cooler. It's still quite cool. The other one used to get, well, I'll just put it this way, make a very useful hand warmer. Right, okay, so let's go up with the voltage. Stop waffling on and get on with it, shall we? 10.399, 10.8 volts. Right, so we're up to 11 volts now. So I'm cranking the battery simulator, 11 volts here, but we've got an indicated, yep, 11 volts is fine, 11.093. So yeah, it's pretty accurate. It's more accurate at the higher range than the lower it gets, the further out it seems to be, okay, in terms of voltage accuracy. So what did they say that the 5 amp should reduce, according to this, 10.5 to 14.1, so at 14.1 it should drop to 3 amps. Right, 14.1, so let's wind her up. 13 volts, 5 amps still. There you go, it's dropped to 3 amps at 13.7. Okay, so it dropped to 3 amps at 13.7. Yeah, so that's wrong. Well, it should drop at 14.1. It's dropped at 13.7.69, so that's wrong. I mean, it's 0.4 out on that spec there, so that's not right. Okay, so does it make any difference? No. I mean, the reason why you drop the charge voltage is that, or the charge current is that as the battery becomes more charged, then if you charge with too high a current, it can damage the battery. Alright, so the idea is to tail off the charge current as the voltage approaches fully charged. But it's supposed to be 14.1 and it's happened at 13.7. It's dropped to 3.16 amps. So anyway, it should stay at this level, this 3 amp level, up to 14.8 to 15.1 volts. Alright, so let's crank up to 14. Let's wait for this to change, to drop down to 0.8, I think. Come on, baby. There you go. She's dropped to 0.8, and the light went out. That was interesting, isn't it? Yeah, 14.43. That happened. 14.4. So Yeah, so again low. We've got 14.4 instead of 15.1. So it should have started minimum 14.8 with the 0.3 range there. We switched over 14.4, so that's lower. So your battery will charge a bit slower. Even though you've got a 5 amp charger and your battery is not fully charged, it's dropped to 0.8 amps. So it will take longer to charge than it could, according to the spec, because it switches the currents down at a lower voltage than advertised. There's no specification really, is there? It's just a cheap as chips battery charger, let's face it. So we're indicating fully charged up here, although there's quite a lot of charge still to be left in the battery. So charge is not yet complete because we've got 0.8. Okay, so let's make that 14.2. Right, okay, so let's crank on and see when it completes the charge. It says here in the book, in the good old book, we're looking for a 15.1. Between 48 and 15.1 it drops to that. A battery, it doesn't say when it stops. So it implies that it should drop to 0.8, but it doesn't say what happens where the trickle cuts in. It's kind of contradictory, isn't it? Because that's my meter again. Yeah, it implies. It doesn't say when actually it drops to this 50 to 150 milliamps, because we're cruising along at 14.5 and we're still pushing out the 0.8 amps. Okay, so let's turn it up and see when it actually completes the charge, which is not specified in here. So at some point that 0.8 will drop down to 50 to 150 milliamps. Okay, here we go. We're turning her up. Still not dropped. 14.8, 14.9 we're charging. We indicated 15 on the screen. There you go. So it was 15 volts, just over, shade over 15 volts. It dropped to 75 milliamp trickle charge current. Now if I'm just wondering what happens if I increase the voltage further. So my battery is starting to boil up, it's fully charged, and the 75 milliamps is fizzing away and at the electrolyte and turning it into hydrogen oxygen. And if it's not a sealed for life battery, it will just go off as gas rather than recombining. What have we got here? 15.2, 15.3, 15.4, still 75 milliamps, 15.7, 15.8. Oh, that okay. So yeah, 15.8 volts, 7-8 volts. It switched and it's turned off. Okay, so no charge current. The thing is done. Charge complete. It shows there at 15 volts, which is a bit high, actually, but it's not specified in the book. That is not specified. All right. So now what happens is your battery is fully charged, okay, and you can, it's absolutely supercharged, and it's all topped up and everything else. The charger is shut off. So I wonder what happens now if we reduce the battery voltage. So we'll make the battery terminal voltage drop to 14. It's slowly discharging itself. Okay, nothing happens at 14. Alright, so nothing happens at 14. Should we go down to 13.8? A fully charged battery should, when it's relaxed and the charge has been over for a while, should go down to about 12.4 volts, I think. Yeah. So 13.8, we've still got nothing coming in. Okay, let's go to 13.6. Yeah, well, it's misreading slightly, but it's still not doing anything, is it? Okay, let's go down to 13 volts. Let's not mess about anymore. Let's just go, right, I'm going to go flat, baby. No, still no charge coming back in, so your battery's dropped to 13, which is technically correct, because even though it's not fully charged, if it was on the charging cycle, you'd carry on, as we just saw. But for a resting battery that's not doing anything, then that's fine, okay? So we're at 13 volts. Let's kick it back down to 12.5. Alright, look, there we go. So we got back to our 75 milliamps, alright? So now if I lower the voltage, okay, so this is a leisure battery, right, and there's a bulb in your caravan, and you just turned on a 10 watt light bulb or something and you've got to turn it off. So we're going to reduce the battery voltage. So I'm simulating the charger not providing enough charge, enough current to actually power the light you've left switched on. Let's see if it just goes flat or what happens. Right, so let's turn this down to, so let's try running it down to 12.4, see what happens. Still, so let's turn this down to 12.4. Okay, so we're still 12.5 volts, we're still at 0.8 amps. Let's go down to 12 volts. Right, so it's holding up at 0.6, so let's run the battery down a bit further. See if it comes back in with the full Monty charge, or whether it cuts out, what happens. So your battery is going successively flatter because you're pulling more than 0.8 amps out. 9. Go down to 8 and see if she kicks in with any more power. So this is the problem. It won't maintain a battery if it's used for, you know, leisure, i.e. you whip out to your caravan, you leave the light switched on, as I explained, and expect the charger to start pumping the 5 amps to hold the battery up, and it won't. It will just let it run flat by only supplying 0.8 of an amp in charge. So we're down to 8 volts. We're almost at the cut-up at 7.5. So let's go down to 7.3 volts. So let's take her all the way down and just confirm that the charge won't come back on. Will it start flashing and go into that weird flashy flash mode? No, nothing's happening. So really, yeah, I mean, it's not a maintenance charger, is it? Because it wouldn't, if you know, after it's done the initial charge and been through its charge cycle, the power hasn't been turned off and on, it will never provide you more than 0.8 volts, 0.8 amps, shall I say. So let's whizzle it back up to 10 or something, or let's go back all the way up to the top and see whether it actually kicks in with any more charge. So we're 8.8. So your 0.8 is managing to recharge the battery. Will it ever kick back in with the full amount? $11.15. It's dropped to 75 milliamps at 13.9, which is normal. And up here it'll just drop to 0 again. Yeah, so yeah, it does initial charge and then will only give you 0.8 amps or the 100 milliamps. So not a lot of cop really for a leisure charger. So let's just do a simple thing then, where we'll set the battery charge voltage to 10.4. Alright, so we'll go 10.4 and we'll say okay, our battery's only run down to 10.4 volts. Let's set this to, so I'll turn the battery charger off. Okay, so your battery's only at 10.5, it's not dead flat, it's 10.5. So we'll turn the charger back on. And it's flashing 10.4, it's going through this 2-minute delay. 10.3 volts on the battery, 10.4 indicated. Doing this, I don't know why it's waiting, do you? Is it waiting to see if this 10.4 volt battery actually decays away to below 7.5 and it's a 6 volt cell attached? That doesn't make sense at all. You know, if it's 10.4, clearly a 12 volt, give me some charge straight away, please. Please give me some charge. 2 minutes to go. Come on, baby. I'm dying here. Give me some power. So cheap, 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 yes. Useful, debatable. Not a charger to get you out of trouble, I'd say, and not a charger to maintain a leisure battery that occasionally has loads, you know, in the cabin, in the caravan, in the boat or whatever, that you could leave something on or an alarm. There we go. So at 10.4 we've kicked in at 0.8 amps again. And now we can go into car mode and let's see if it goes straight back to 5 amps this time on car mode. It does. Right? So at 10.4 volts on your battery, you'd have to wait a couple of minutes and then press the button to get your 11.1 volts. And that's what my load is. I'm simulating a flat battery at 11.1 now, so we've got the full 5 amps. Now if we press this on the other one, yeah, we used to get that. It gives you the current. So this bug is still here, which I reported last time. So you go into car mode. Oh no, we haven't got to go through that again, have we? We have. Let me just turn the voltage up so we can go straight back into a sensible charge. Yeah, we can talk a bit more about it, a bit more effectively now. So we got a 12.1 volt battery now. 12.1. Make that 12.05. Enter. Right, okay, so there we go. So now we've got 12 volts, we can go straight in. So press it once, you get that. Press it again, you get that. Press it again, you get the car, and it ramps up to 5 volts, which is lovely. 5 volts charge. So if your battery's not too flat, it will get you up enough to run your car. But if it's gone a bit too low, it won't recover it very well. It'll take a long time. All right. So now if we just so what I was going to demonstrate was that if I hit this button, you can actually get a current reading. But watch. As well as going into current mode, it also goes into cold charge mode, which will give you higher termination voltages. They're in the book. They're probably approximate again. So if you're interested in what the current was, then you can only go into cold charge mode. So we can go back to there. There you go. Now press it again. Oh no, maybe it doesn't do it this time. Look at that, it's changed phase. We're in no mode at 5 amps. Work that one out. So there's some bugs in this software, isn't there? Look, watch. Motorcycle mode. Cold mode. Car mode 5 amps. It's not displaying the voltage anymore. 5 amps with no mode. And then back to there. If I turn the power off, power back on again. Car mode, and then it shows you the cold mode for motorcycles and cars, 12 volt. Yeah, what's happened to my voltage display, everyone? Oh, we are. So it switches back. All right, okay. So if I want to see the current, it's not alternating. It'd be nice if it just kept alternating between current and voltage, don't you think? You know, every few seconds, so you can see the progress of what's happening. They probably don't want to do that because they don't want you to display the current because it doesn't match the voltages in the book. And if I press that again now, I can get the current, but it goes into cold mode with no indication up here. And let's see if that switches back to voltage now. Yeah, it does. But if I press it again, we go into cold mode. So we'd like to see that alternating back and forth. That would be the best thing. So what's wrong with this charger? In summary, if you have got a 12 volt car and if the battery is slightly flat or quite flat actually, you left the lights on and it's run below 10.4 where it was, you're going to have to wait for this 0.8 amp, this 2-minute wait for it to actually start doing anything. Then it will go into this 0.8 amp mode, and at that point you can then switch to the car mode and wait for it to recover. But you won't get your full 5 amps until the battery voltage reads 10.5 amp volts. So what were we on there? We're on 12 volts. Let's just turn it off. Set the battery to 10.5. Ignore those readings for the moment. Right, so let's just turn the simulator down to 10.5. Alright, so there you got it. So I'm just going to turn her on. We've got 10.42, actually 10.5 indicated up there. So it's a little bit out, so I'm going to have to turn this up. 10.5 volts. So, okay, so at this point when we turn it on, according to the spec, we should get a full 5 amp charge. No, it's doing the 0.8 amp shuffle again. Why is it doing that? Oh, I see, because it's in car mode. Alright, so if I press this once, we should go straight to 5 amps. Oh no, cold mode, and then 5 amps. It does, alright, okay. Yeah, so if your battery voltage is below 10.5, you've got a bit of a weight on your hands, to be honest. And if your alarm is playing up or drawing current, or the battery's got high internal leakage, then you probably never get back into the recovery mode. So not a good charger for emergency use. A charger for maintaining batteries which aren't connected to any load, or if they're in circuit in a boat and there's alarm or something else which could drain the battery, it will never kick in with more than 0.8 amps charge. Alright, it'll let you run it all the way down and just providing 0.8, rather than saying, oh, it's dropped to 10.5, therefore I'm going to give it a 5 amp charge now because there's something drawing this battery. So yeah, maintaining batteries fine, cold weather mode probably fine. Can't bother to test all that, to be honest, but it is pumping out the 5 amps as advertised. Should we have a look inside? Do you want to see inside it? Yeah, let's do that. Let's do that next. Anyway, so that's that bit over. Any questions you've got on that should be straightforward, but I have been waffling a bit, so if you want more information, then just leave me a comment, and because I do answer the comments and I learn quite a lot from them myself. But that's the latest one on sale, alright? And it's showing 11.5, and obviously at 11.5 it's saying the battery is completely empty, because it would be pretty much totally discharged. Yeah, so I'm just whipping these screws out. You need I've taken the screws out. They're these little triangular screws. Look, got triangular top in them. See that? See that pretty clearly. Yeah, we use these security bits here, these things. Yeah, anyway, they feel nice. They've got a nice traction in the plastic, so it feels quite good quality. Nice long screws, really, to test this. I think it does make a big thing in the manual about screwing it to the wall. So I think so. Take the lid off. So you've got a rubber seal, so IP65 it says in the manual, which is dust proof and splash proof. Not really driving rain proof, which would be IP66. All right, so the first digit is the dust ingress, and the second digit is the waterproofness of it. And yeah, no CE marks on the plastic for recycling, so it's not CE approved really, usual thing. And yeah, here she is. Crikey. Nice. So let's take her out, shall we? Get her out. Pull this plug off. It is unplugged, I've checked. Now, the fact that this was slightly cheaper than the last one I bought makes me wonder if they've managed to do a drastic cost reduction in the design. That would be interesting. Aldi and Lidl keep ping-ponging their specifications. One released 3.2, then 3.8, then 5. Lidl was the last one that did the 5 volt, which is probably about 6 months ago, I think. And now Aldi have now upped their current to 5 amp now. Interesting enough, if you look in things like the UASU battery resellers manual, there's all sorts of guidelines in there, but also the specifications for the batteries themselves specify the recommended charge current, wait for it, is just 3.8 amps for most car batteries. So actually, by charging at 5 volts, you're actually exceeding the manufacturer's recommended charging current. As to whether that will actually do any damage or not, I don't know. I can imagine when you fire your car up. It's nice that they've put plugs on. They don't do that on the C-Tech, I can tell you that. So anyway, mains input plug, live and neutral brown. A little bit of a nick in the cable there, look. See what they put the connector on and crimped it. I'm sure it's not going to kill anyone. Hopefully not me. So that's this one here, and yeah, let's take the old one apart, shall we? Take the 3.8 amp version apart and see what they've done to improve the current output. To be honest, the power supplies are so crappily redesigned. They may have just done a bit of design work on the power supply and made it more efficient instead of getting very hot, which this one does. We'll run them both together in a minute and get the old thermal camera out and just see what she does, just out of interest, shits and giggles and all that. There we go. Talk amongst yourself while I have fun. removing the screws. Bit too cheap really, I'd say. If you consider average battery is like 70 to 80, 100 pounds, a leisure battery probably at least 100 quid a battery, then 10 or 15 quid on a battery charger is probably not a good investment. You're probably better off spending a bit more on a decent one that's designed to support leisure batteries and will kick in with a full charge as well when the battery is run flat again, which this one doesn't, does it? Right, okay. Alright, okay, so screws, and there are some screws in there as well. Let's take those out. Talk amongst yourselves. The dog has just come in. That was my meter beeping, not your computer. Looks like there's just only one screw in this one. So we've gone from one screw to 3 screws on this one. So that one's got 3 screws holding it, and it's going to got 1. So let's pull those out. Let's remove the gubbins. Come on, baby, you can do it. Or maybe not. Maybe there's supposed to be more screws. That's a screw I dropped. Actually, no, there are 3 screws in there. I've just pulled them out. But look, the pillar is split on that one. It's that cheap styrene plastic again. I told you about. I warned you about. Oh, look, on this one, that's interesting, isn't it? Look, this one, the mains input connector is soldered onto the board here, direct soldering connection, whereas this one is plugged, so that's an improvement from the maintenance point of view, because I can't get this one fully out of the case without actually taking the cable out. So if we just turn them both over to start with, we can see the pertinent differences. Turn them both around the same way. So what have we got? We have, interesting enough, there's the 2 side by side, new one, old one, 5 amp, 3.8 amps, much smaller transformer. Look at the size of that transformer. Look at the size of that transformer. MBR on Aldi. MBR 2010 below. Yeah, so you've got slightly bigger output transistor, very much the same filtration and thermistor. Input filtration is bigger. Look, beefier input filter. Can you see that? Much bigger actually. Higher current. This is all very much similar. Most electronics are on the other side. On here we've got an additional capacitor there. Got the same class wires, same opto isolator there. A bigger secondary smoothing capacitor there for the 5 amp side than this one. It looks, one's got a, what have we got there? 320 UF, 320 microfarad versus 470, so we've got bigger secondary smoothing. They've done a better job actually than the Lidl 5 amp. The Lidl 5 amp's got extended heat sinks and things because it does get quite a bit hotter. And then you've got your input mains fuse. Actually, that's the output filter, isn't it? That's the output common mode choke filter, stop the switching noise going down the leads and radiating out the battery leads. This is the input filter, which is obviously the same. The mains current's going to be pretty much the same on both of them, and the same filtration components there. This one, actually, look, they've had an additional filter on the input side of the filtering capacitor on this one, but this one they've just left it out. They've just put a voltage dependent resistor there as a protection, so there's less filtering on the input, but presumably they've done CE testing. Maybe what happens is with these small transformers that are heavier, I'm rambling now, with small transformers which are more heavily saturated, you get a lot more switching noise, and the peak current in the transistor is much higher due to the stray inductance in the transformer. So it seems counterintuitive, but bigging a bigger transformer in probably makes it more efficient and also cuts down the switching noise. So they've been able to omit this choke here, which is the choke which filters out the switching noise from the actual circuitry here and stops it radiating out the cable, causing EM interference. All right. So otherwise, pretty similar. Bigger transformer, a couple of extra components, another capacitor there, so there's something on the input side. Now if we look down on the back, so I'll just move this around like that, turn them over, you can see the circuitry, I should imagine on this side, still checking it's not turned on. I do not want to die. Get the display off. Same display, same part number, no changes there. And on the new one, they've it looks pretty similar, doesn't it? Oh dear, that's okay. So we've got the same power supply management chip. It looks like almost identical circuitry actually, doesn't it? Even the layout on this side is very similar. Not the same though. And interesting enough, I mentioned last time that the designer on the Lidl one broke the corners on all the tracks, where whoever's laid this out has done the same. Yeah, different track layout here, look for this. So there's some minor tracking differences, and they broke the corners there and broke the corners there, so you know, yeah, very similar. Difficult to say whether we're designed. You can see here this silver masking here where they've overlaid the etch resist with a matrix to actually pick up some solder during the soldering process to effectively reduce the impedance of the tracks. You can see some raw copper there where it hasn't quite worked. Look, it hasn't quite taken in the wave solder machine. So this is the low current one, the high current one. Right. So yeah, generally quite a bit beefier design actually, with beefing up of the tracks with wave solder to effectively thicken the copper or reduce the resistance of the tracks. Yeah, so very similar layout. So should we power them both up and just see who wins the heat stress competition? So what I'm going to do is I'm going to fire them. Don't let them short out. Good idea not to do that. This is annoying, this actually, isn't it? Very annoying. Right, let's go back out. Right, there you go. So they're both running at motorcycle mode. We've got 12.6 and 12.7 volts. They're indicating different voltages, which is not surprising considering the electronics they use. Now if we just hit the tiddy button and then go into car mode, there, 5 amps on that one, 3.8 amps on this one, not cold mode. There we go. Yeah, so there's a 0.1 volt reading. So they're both running. They're basically both running full chat. On my load, it's indicating I've got 8.81 amps flowing in. If we look at the meter, they're both feeding into the load via the 8.83 amps. Right, so they're both going at full chat at the moment, as you just saw. So it's a question of a waiting game and just see which one gets the hottest, shall we? Should we have a competition, see whether the 5 amp one runs cooler, which I think it's going to actually, than the 3.8 amp, purely because they've beefed up and had much more sensible. That transformer is much bigger than 20% bigger than that one, which is the only difference in the actual output current. So I can hear the fan in my electronic load spinning up to dissipate the heat that's being sent in there. We've got 108.94 watts going into the load at the moment. So very similar, but it's interesting that this one was less than I paid for that one. I don't think the exchange rate has fluctuated massively since 2019, but I don't know. I'm guessing that this thing here is actually the current shunt. Just a loop of wire so that we can generate a small voltage across there to feed back into the electronics to tell it what the current on the output stage is. Not going to touch anything around this side because that's the mains side. Anything left of the transformer and left of those capacitors is at mains potential. Right, I've been working on the video dicing and slicing, and this has been running for about half an hour. So what have we got? Yeah, mildly warm, hotter, definitely hotter. This one, the actual heatsink for the rectifier. Ooh. I can hold my fingers on there, but not for long. This one's much hotter on that side, much hotter. I'm not going to touch that at the moment, but let's have a look with the old camera and tell you what they're running at. Easiest thing. FLIR. Where are we? Just here. I would have said that was hotter than that, you know, by touching it, but you never know because it is reflective metal. But it's reading 53.9, and this one's reading 48.2. That's not accurate, actually. This one is running much hotter. I can't keep my fingers on there for more than half a second, whereas this one is not too bad. So it's running. This one's running quite a bit hotter. What about the transformer? 55 on the transformer, 49 on the on that one, and then the switching transistor, which is here, 45, 38, 40. Yeah, so the 5 amp one is running much hotter on the secondary side, basically, as you'd expect, because it's got the same diode in there, and so more current, more dissipation, more heat. So that one's effective. Actually, is that actually bigger than that one? Careful with this. Careful. 50. Yeah, so that heatsink is actually bigger. The board itself has been made wider to accommodate the extra power and the bigger transformer. So interestingly, the higher current one has got a lower component count, because if you look, there's less components in here. There's a couple of capacitors missing out, or one capacitor missing out of this side. No, 2 capacitors missing on this side. 1, 2, 3, 4. 1, 2, 3, 4, 5, 4, 5. 1, 2, 3, 4, 5, 6. 2 capacitors. 2 capacitors missing there. Yeah, that one and that one missing. And then we've got the input choke is the differential common mode input choke is missing as well. So we have got a slightly larger B plus smoothing capacitor. So yeah, all in all, not bad. I mean, it's got the same foibles and pitfalls as the old one. It's just a higher charging current for a lower price with fewer components. One thing I have noticed in these is, I know from a fact, because I was using an angle grinder on my car and I had one of these plugged in, and I was turning angle grinding the rust off, and lo and behold, a big cloud of smoke and a bang, and I blew up my battery charger because it was plugged into a long extension lead, and it was causing a kind of a whiplash effect of the voltage and put it up. So before I put these back together, I'm gonna stick in a decent varistor actually across the mains input after the fuse. Okay, I've just taken this varistor out, which is a VDR, but it's so small that you know, you more or less, a slight fart comes down the main and it's screwed. The trouble with things is, if you hit these things with the impulses, they then, you know, if you're plugged in and this is a support charger, every time you get a surge down the mains of a certain energy, number of joules, it will affect this and basically slowly destroy it until it won't work at all. Either it'll blow the fuse or not protect the unit any longer. So the normal size, and you can see the normal size that you would fit in an ordinary, you know, piece of decent equipment like a TV or an amplifier would be this big. You can see there's no comparison. They're both 275 volt AC, 430 volt DC working, 350 volt DC working. So yeah, I'm going to put these in instead. I've got a couple of these. I'm going to put them in my charger because I want it to be protected, because I fried a few chargers by using power tools on an extension lead whilst I've been charging a battery, and they don't respond well to it. So I'm just going to put these in. So yeah, so what it's worth, if you want yours to last, you might be a consider putting a 50p varistor in it and then have the unit last much longer, because when you get those surges coming down and they're not arrested, it blows up the capacitor, the input capacitor, or usually the switching transistor. So let's give it a fighting chance, shall we, and protect it. If you like the video anyway, so that's in there now, I can just snip that off and put it back together. I hope you found that interesting. If you want to see more videos or you've got some comments, then well, if you want to see more videos, then subscribe to the button down there and leave me a like for my efforts. And if you have any comments or questions, then I'm happy to answer them for you. I hope you enjoyed that.